exciting. Anyway, my talk is called the Operable Front End, and I'll just dive right in. My name is Emily Nakashima, as you heard. You can find me pretty much anywhere on the internet at EA Nakashima. I work for a company called GitHub. Can I get a show of hands as to who has a GitHub account in the room? Yes, okay. I'm used to working for companies where I have to explain like what the company is and what it does, and it's really nice to not have to do that. I was hired at GitHub to be a JavaScript engineer, but so much of my job doesn't actually involve writing JavaScript for features. I write some JavaScript for new features, but my team also does all of this other stuff in various parts of the stack. Most of the work that I do is probably better described as front-end ops engineering, maybe front-end infrastructure engineering. I know Etsy has a team that uses that term. Or my favorite is front-end platform engineering, but nobody uses that term except for me, so I don't think it's going anywhere anytime soon. So I will just say it's a little bit complicated, and I'll come back to what I think it all means a little bit later. Before I forget, I should mention that if you want to go look up any blog posts or articles or references that I mentioned, you can find links to all of them in the bit.ly bundle for this talk, which is at bit.ly/operable-fe. First, to just get us all on the same page, I want to talk a little bit about what is operability. If you work on the back end of a web application, you may use this word already, but if not, I want to define it and I want to give it a little backstory. When I first heard this word, I was working at an e-commerce company. We'll use this site, which is cashcats.biz, as a stand-in for that company. They both involve fashionable animals, and so you can sort of picture what it was like to work there. Anyway, one day, cashcats.biz. One day we had a big sale, and we had some downtime, like because we just fell over under so much load. And afterward, the director of engineering decided that we need to do an RCA. An RCA is a root cause analysis. And if you've never done one before and your team does like blameless postmortems or something like that, instead you should be grateful. Because an RCA is basically the opposite of a blameless postmortem. It's like a problem happened and you're going to find that one person responsible and you're going to like blame them for all you're worth. So we get the app developers and the ops engineers all sitting down in this one big room to do the RCA together. And the developers say that thing that they always say that the ops team hates so much. We're like, ooh, database fell over. Sure sounds like an ops problem. And I remember this very clearly. One ops engineer turned to us and said, if you just wrote operable software, we wouldn't have this problem. And I was like, what? My software is so operable. I have been operating this software in development mode on my laptop all week. So there. I actually had to go and look the word up. If you ask different operations engineers, you'll get different opinions about exactly what it means. But it typically includes at least this particular set of concerns. Operability requires a strategy for deploying, logging, monitoring, debugging and diagnosing, alerting and scaling. And the key to all that is in production. You have to be able to do those things. This might be worth a diagram. The world is full of deeply mysterious diagrams about operations, and if you ever want to be really entertained, you should take 5 minutes and Google image search DevOps diagram. Some of these are hilarious. So anyway, this is my favorite one. Someone at CollabNet made this. And I don't understand everything that's happening in it because there's a lot going on in there, but there's sort of this one big thing it captures for me, which is that you code and you build your software and you write tests and you release it to the world, and then you think you're done, but you're not done. Like, there's this endless cycle of operating, fixing, and redeploying that happens in that circle at the end. As a front-end engineer, when I hear this word discussed in the context of ops, there are things that don't necessarily apply to me. Like, for instance, like scaling on the front end tends to look a little bit different. Like, you just get more users and make them buy more computers, which is pretty easy compared to what back-end engineers have to do. But the three core ingredients still look the same. We still need to be able to detect when there are problems, diagnose and fix them, and then quickly and efficiently deploy that fix to the world. Operability is really about how easy it is to do everything we need to do after a feature is ready for production. So at that last company I was talking about with the Cash Cats, After that horrible meeting, we really did go back and make our services, all of our applications more operable. We automated more things, we added more endpoints for monitoring, and we put all the data from that up on dashboards, and it was honestly pretty great. We could walk in every morning and look at the dashboard and go, dashboard's green, everything's fine, let's go get coffee. I was like, yay, this is the job I have always wanted, and there's so much time for coffee. But interestingly, as a front-end engineer, I found that there were times when it didn't always work like that, and I started to notice this funny pattern. If we had a back-end problem that caused downtime, there'd be a whole to-do afterward. We'd do a root cause analysis, and we'd change things so that it never happened again. But there were all these other kinds of issues that caused problems for customers that we barely even talked about. Yep, all. And those were front-end issues. One time, we had a third-party marketing tool that released a development version of their script to production by mistake, and it started popping up alerts for customers with random numbers in them. Yeah, it's like someone was debugging with math.random in an alert, it was 1999, and I was like, why? Why would you even do that? But never mind that, this is totally terrifying. Customers think that the site is broken or hacked, and even if they don't think that, they tend to leave really quickly because it's actually really irritating to have to dismiss a pop-up on every page. But in this case, what did we do? Instead of doing an RCA, we just called that third-party vendor, and we yelled at them on the phone until they fixed the issue. That was the solution. Another time with a similar problem, we had a JavaScript performance problem with a third-party script, which meant that our customers were seeing a blank white page for 5 seconds before every page loaded. And I found out about this one in an email from our customer support team. In this case, someone deployed a fix to remove that script a few hours later, and we never even talked about doing an RCA, even though we could see in our analytics that our traffic had plummeted because of this issue. So we were just starting to get rid of that mentality, yeah. I go to all these operations conferences, and every operations engineer loves this meme. It was in all of their slide decks. Anyway, we had just started to get rid of this mentality that oh, it worked fine in dev, now it's an ops problem, but we replaced it with this mentality of it worked in dev, the dashboard is green, everything's fine, right? And it's right up to a point. Without great front-end monitoring, what this really means is worked fine in dev, dashboard's green, anything else that goes wrong is a customer problem. We can have all the database and app server alerts and metrics we want, and if a customer can't accomplish what they want on the site while the dashboard is green, we still haven't fixed the underlying problem. So there are a lot of ways to help fix these things, and I think most of them fall broadly under the banner of front-end ops. If you've heard that term once or twice but aren't quite sure what it means, it originated in a blog post written in 2013 by Alex Sexton. It's not really a common job title or a true discipline yet, but it does kind of help group together a lot of things that involve what we do with front-end code after we finish writing it. Alex mentions about 20 or 30 different responsibilities of a front-end ops engineer. If that looks like a lot to you, I also feel like it's a lot. But I think that they really collapse down into these 4 distinct categories. The first 3, front-end architecture, web perf, and dev environment automation, I think are really well covered in other conference talks and blog posts, so I'm not going to talk about them too much today. What I really want to focus on is the front-end visibility aspect of this, which is browser monitoring. I think there are very few existing talks that cover this in great detail. I think it's a super interesting topic, and it happens to be something that I think GitHub does fairly well compared to other companies. So I'd like to kind of take a deep dive into that today. So we talked about what front-end ops and front-end operability are, and I want to just do a quick end-to-end of how all the pieces fit together. Here's a typical day at my job. I go into the office. Usually one of the first things I do is open up a couple of dashboards and websites. This is a custom front-end performance dashboard we have. Take a look at that. Everything looks normal. Nothing has changed from the day before. The next thing I'll do is usually look at our JavaScript error dashboard. Usually there's a few things in here that kind of look familiar, intermittent errors that we see from time to time, we haven't tracked down. That's all fine. Very occasionally, though, we'll see an error that's new, that sounds suspicious, and that's happening to multiple users, and that's usually something I'll want to dig into. So here's an example. The error message here is pretty interesting, pretty suspicious sounding. The error is reference error, editor is not defined. So I look at the error message, I look at the page that it happened on, I look at the stack trace, And the stack trace will enable me to easily go find where the error happened in our JavaScript code. OK, so at this point, it's actually not that easy because our JavaScript is minified, and we don't have source map support yet. So the error is always on like line 1 at like column 32,015. So then you have to like dig through your minified JavaScript, like find the code that's throwing the error, search for it in the app, and then here you are. So it's like easy-ish. It's not easy yet. Source maps, someday it will be. So it turns out that that code shows a drop-down menu that lets you automatically insert license text for like the GPL or the MIT license into a file if you're editing a file that has a special name like license.txt. An interesting side note of this is a feature that I didn't actually know existed before I found this bug. It was built before I joined the company. I'd never looked at it before. But of course, like looking at the code, I can figure out what it does, and I can see how it could throw an error. So I fixed the error, hopefully added test, from being a good person that day. I deploy a branch with my fix on it to production. And we deploy by typing a command in a chat room. So just type that command, deploy GitHub, name of my branch to production. That'll kick off our tests, which take about 2 minutes to run. And then after that, it takes another 2 minutes to deploy to all of our servers and restart them. So while I'm waiting, I have a couple minutes to check a few things. First, because I know that we have a very helpful and very technical user base, someone might have already spotted this and written to our support team to tell us about it. So I jump into our support emails, and I look to see if any users have reported this. And of course, there's like an email about this issue from 20 minutes ago. Nobody on the support team has had a chance to answer it yet. And I know that since I just looked at this bug, I'm in the best position of anyone in the company to answer this email. I have just become our company's like leading expert on this bug. And I can save our like super busy support team the work of having to figure out what's going on in this email, verify that it's really a bug, open an issue with the right team, figure out what that team is, and then find out that it's already been fixed and have to email the user again. So I can just jump in and say like, hey, thanks for letting us know. I'm deploying a fix for this right now. Like, let us know if you run into any more issues. Then I flip back to the JavaScript error dashboard. Normally, after the deploy has gone out, this is the point where I'd celebrate and be like, yay, but not today. It turns out that the same code also controls the get ignored chooser, which is on another page. And I didn't see that, and I only fixed the licensed chooser. Oops. So I jump back into the code, I fix the second context, redeploy the branch, and then look at the error dashboard, verify that it's gone. And an hour later, I'll get an email from that same user saying, it seems to be fixed now, like, thanks. Obviously, in a perfect world, we'd never break anything. Like, we want our users to have a consistent, high-quality experience on the site, and we're working on that in a different conference talk. But even if you test really thoroughly, like, unless you have like a small army of QA people that look at each change for hours, there's always going to be something that slips through the cracks. So in this case, I can look at my stats, and I can know that this was broken for about a day. About 5 people ran into the issue. It's not perfect, but it's a lot better than having to find out about this issue from the support team after half a dozen users have emailed about it. So that's kind of how the pieces fit together. That was like the how of how we use monitoring for better front-end visibility. But I think the what to track piece is even more interesting. So what do we want to track? The short answer is I think we want to track everything that helps us understand our end user experience. The traditional 3 big buckets here are errors, performance, and user engagement. And along with those 3 things, we've also come up with a few less common things that we also think are important that we want to track. And those are security. So in the browser context, this typically means like XSS. We want to look at accessibility issues and track those. And we also want to look at browser feature support, because we're often trying to use new browser APIs right away. And so we want to understand what our audience's browsers are capable of. So just to jump right in, deeper dive on each of those pieces. JavaScript errors. The client-side script to collect this is actually pretty short. We package this up with our JavaScript. All of our users will download it and run it. It really doesn't take much code, just enough to collect some context information about where and why the error happened. So it starts with an on-error event listener, which will let us grab information from the error itself, which would be like the error type, the error message, the file name, and the line number. And then we'll typically start to collect some additional context from the page. So we'll want to know Some browsers also provide a stack trace for the error, so we'll want to grab that if it's available. We want to know the URL where the error happened, and we want to capture the document ready state and a time since load, because we want to understand if this is an error that happens immediately when you're starting to load the page, or if it only happens like when you've had the page open for a long time, or after you've triggered some sort of event. We're also going to take note of the event target, of the event that triggered the error if there was one. For example, like did this happen when you were clicking on a button or like typing in a form field? And this will all help us try to reproduce the error really quickly. So we take all that information, we send it all back to the server. And then the server parses out the JSON. And then the key thing that we do that a lot of third-party tools don't do as good of a job with is that we actually do a ton of filtering to get rid of errors that we know aren't relevant. We probably actually filter out even more errors than we ever record in our tools. Some of the errors we found come from like browser extensions that are badly written, so you can filter out anything with like Chrome extension or like file in the name. It's typically a browser extension. Sometimes we see errors from like inquisitive developers who are like running some weird JavaScript in the browser console, like testing stuff out. So we filter those out too. If there's no file name, then we often know it's one of those. Some errors will come from pre-release versions of particular browsers where some API has been broken, but we feel pretty confident that it's going to get fixed before that browser goes out to all the users. So anything like that, that's fine. We just ignore it and filter it out because we only want to see stuff that we might want to take action on in our tool. We send all these error reports to an application we call Haystack, which I showed you earlier just for a second. One of the really interesting things about Haystack was that it wasn't actually built to handle JavaScript errors at all. We built it to look at errors from our backend systems, but it turns out that an error is just an object with a message and a bunch of related context information, and we found that as long as we format the errors correctly, we can use this for our JavaScript errors too and see everything in the same place. Haystack will help us see how many errors happen, which is that kind of bar of tick marks along the top. We'll see how many errors of the same type happened. And then one of the most useful things is we can see, are these errors correlated to a deployment? So you see the avatar of the last however many people have done a deployment. And then finally, we can see, do any of these errors have an open issue on github.com that's related to them? This will help us know if someone else already knows more about the issue than we do, and we can take a look and see if they're maybe already working on fixing it. So this is it. This is most of what we need to answer the question, like, did my change break anything? Or like, did my fix really work in real time? And then Haystack also has an internal API, and so someone wrote a script so that we can check errors from chat. So remember, I'm already deploying from chat, so this means that I can deploy and check my monitoring from the same place. So kick off a deployment. I watch to make sure I see my green test builds. Of course, the deploy won't happen if the tests are red. And then when my branch is finished deploying to production, I can type chat commands to check the errors, which is the text with those little histograms. And I can also check performance to make sure that my branch really fixed the problem and it didn't make anything any worse. And the important thing here is that not only can I see this, but my coworkers who are in the chat room know that I'm looking at these things too. So that way, if someone else is looking at the same problem I am, like we can share notes, or like if things are looking bad and performance got slow, or there's like more errors than there were before, my coworkers know that I see that, and I can just redeploy master and put things back to the way they were. But if things seem okay, then I can merge my fix, and everything's all set. If you want to know more about how we use these chat tools at GitHub, there's a great talk from last year's Monitorama that's in the Bitly bundle, which I would recommend checking out. So that's sort of an end-to-end view of what like an operable front end looks like. Like we have good visibility into when features break. When we see problems, we have enough context to jump in and be able to fix them pretty quickly. And then, of course, our ops engineers have done this great job of enabling us to deploy new code really quickly, so it's fast for us to get our fix out into the world. The other big bucket that I talked about was performance. This one is particularly close to my heart. There's a very strong correlation between how fast your site is and how much your users will actually use it, how many pages they'll view, how many things they'll buy, how often they'll come back. For front-end performance metrics, there are kind of two big categories. There's synthetic metrics, which are numbers you collect from controlled environments, like audits you're going to run from your browser developer tools, or tests you're going to run on like something like web page test, which I highly recommend. It's a great tool for performance debugging, profiling. And then the other big category is real user metrics or RUM metrics. And those are metrics that you're going to collect directly from users' browsers. Both types are really useful. I like to think of synthetic metrics as more of a debugging tool or as part of your test suite. It's great to use them as part of your continuous integration system so that you can use their consistency and their high level of detail to catch performance regressions kind of as people create them on your team. Real user metrics, on the other hand, you should hook those up to your monitoring and alerting infrastructure because it'll tell you what it's really like out there. You'll catch all kinds of problems that you can't catch with tests. That's what I want to focus on right now. RUM metrics are particularly critical if you're working on sites with lots of third-party JavaScript, like I said. A lot of A/B testing frameworks and third-party monitoring tools, third-party marketing tools ask you to add a script tag to the head of your page. And then, of course, like if that third party is down or it's slow for some reason, even though the dashboard for all your backend infrastructure might look green, you're going to have that same problem, like where your users are just waiting and staring at a blank page. And so you want to know about that and fix it really fast. If you're tracking any browser metrics now, like you probably are already tracking time to window load, which is great. Like if you have a front-end metrics dashboard that just sort of shows one big number, it's probably this number. I've been a really big New Relic fan for a long time, and I like that it keeps that time to load number really prominent at the top. Like, I think it's a really great way to give people one simple thing to think about, and it's a great way to keep your team and your company really excited and really motivated about performance. But day to day, I like to have a number with a little more granularity. For one, if this number starts suddenly going up, when you have the one number, you know that there's a problem, but it doesn't help you pinpoint where the problem is. For that, you want to track lots of different parts of the request individually. So the navigation timing API is the answer to that. It lets you collect metrics at all these points in the request cycle. If you've never looked at navigation timing before, like it looks like a lot, like it looks really scary. I demoed this talk for someone and I was like, I want your feedback. And she was like, that navigation timing diagram really scares me. Please take that out of your presentation. And I was like, oh, okay, good to know. But the point is just, you can track every part of the request individually. From TCP connection and SSL negotiation time to downloading embedded assets like images. And that all comes together to be part of that time to load number. So when the tool only shows you one number, just remember that you're not getting the whole picture. At GitHub, we collect most of the parts of the navigation timing data, and we find them pretty useful. We use them to make a graph that stacks up the different parts of the requests so that you can spot what's slow more easily. You'll start to see like one layer will get thicker, even though the layers below it continue to look normal, like it'll sort of look like a snake that ate like a cake or something. And that's, you'll be able to kind of see where the slowdown is by finding those. In this case, like this graph is showing us something we already know, which is that responses take longer to get from our servers to users outside of North America. And those users are a larger percentage of the people who are online around midnight Pacific time. But when we see an unexpected slowdown, this graph is also the first place I'll look to try and diagnose it. You might see a performance regression in the JavaScript library by looking at first paint times. If we're having a CDN performance issue, we'll see that really clearly in our DOM complete time, since that'll be like showing us that all of our images are loading more slowly. So different types of performance problems start to become really obvious visually with a graph like this, because you'll always see them manifest at different points on the graph. So those kinds of metrics are all the loading metrics, and those are built into a lot of the out-of-the-box commercial tools you can get, which is great. But there are a couple of other aspects of performance that are important for us to track too, and those take a little more work. For one, there are cases where we want loading metrics, but we don't get them by default. On GitHub, we do a lot of navigation around the site with a library called pjax, which is a framework that lets you navigate a little bit faster by loading the next page's content with ajax and then only replacing the piece of the page that changed. If you use any kind of single page app framework like Backbone or Ember, like you're doing the same thing. This is what I'm talking about. These frameworks all make ajax requests that are analogous to page loads, but those requests don't come with navigation timing data because there's not actually a navigation from the browser's perspective. So there are two other browser APIs that we can kind of put together to create our own fake navigation timing data. And those are the user timing API and the resource timing API. The user timing API is for basically just choosing your own timestamps that are important and instrumenting them yourself. And the resource timing API is for getting load data from other assets you're pulling into the page, like images. So our library pjax makes this pretty easy to instrument because it triggers the same events before and after each navigation. So we could just listen for those events and mark a start and end time and then collect that time right afterward. Most single-page app frameworks that handle navigation will have similar hooks to work with, but if not, you can usually jump in and modify your framework code a little bit so that it can be instrumented in the same way, so you can collect stats on all the requests just using a little bit of code. And then if you combine the custom timestamps with the resource timing API data, you get a fairly good overall picture of how fast those requests are, and you can compare it to standard navigations to find out if you're really saving time with your JavaScript framework. And you can monitor those and then alert on them in the same way that you would with your standard loading metrics, which is what you want. The third final aspect of front-end performance that I think is really relevant to users, but is really hard to track, is interactive performance. Think of all those awesome marketing pages you've seen that do a parallax animation as you scroll. This is a classic one that came out a few years ago. As you scroll the page, all of these electronics pieces assemble themselves, and it looks really cool. These pages are really great, but sometimes when you try to scroll down the page, you sort of feel like you're scrolling through molasses, and then when you get to the bottom of the page, you feel like your hand got a little workout and needs to take a rest. And so that's interactive performance, or some people talk about rendering and event performance, or some people use the term jank, which I don't know where that came from, but sure. So depending on who you talk to, you'll hear different terms. But either way, this is something that I definitely would love to have better metrics on. At one point at GitHub, we had kind of a hacky way of tracking this that used request animation frame to basically construct a little frames per second meter, kind of like Chrome has a built-in frames per second meter, but we were running a little bit of JavaScript to do the same thing in users' browsers behind the scenes, and then sending back the data from when users would do computationally intensive activities on the site. That was interesting, but it wasn't actually that valuable. It was a little imprecise because you couldn't tell if you were hitting 60 frames per second really easily, or if you were always really close and just about to go over. Luckily, there's a browser API in the works that will make getting this kind of data a lot more accessible in the future, and that is the frame timing API. There's a very readable explainer on GitHub, which I would recommend checking out if you want a little more detail on this. The idea is that it lets you compare the timing of main thread or renderer commits to compositor draws. So basically, when you're animating or scrolling, the browser has about 17 milliseconds to draw each new piece of content onto the page and make it look smooth. So each 17 milliseconds is a frame. And there's usually two processes that go into making a frame. One is the renderer, where the JavaScript you wrote is running, and you're making changes to the DOM. So there's a renderer commit for each batch of those DOM changes. And then in each frame with changes, the compositor will then take that information and draw it onto the screen. So you can look at how long each of those processes takes, and then you can compare it to a healthy frame rate, which is 60 frames per second, and see if you're hitting it with time to spare, or if you're going over or you're really close to the boundary. This diagram shows something that's slow in the renderer, so you can see that it's skipping a frame, so you know that you might have a slightly stuttery or slightly slow animation. So back to this case. You could instrument the animation on this page, and you could track quantitatively for each of your users, is this animation smooth, is it slow, and if it's slow, how slow is it? So by looking at the timing of renderer commits, you could find out if your users are seeing slow scrolling, slow event performance. And by looking at the timing of compositor draws, you'd be able to infer whether the animation is smooth or kind of jerky. And the best part about the frame timing API is that it uses the same API as user timing API. So if you're already collecting user timing data, it's pretty easy to just start instrumenting other kinds of things and grab the same data the same way. I think the other sort of big canonical bucket that people want to track on the front end is user engagement. This is the thing that really, I think, tells you the most about what your users are actually experiencing. So you really want to instrument the user experience itself directly. A lot of you probably already do a ton of this. If you record events in Google Analytics, you do this. And I think the critical step that some people are missing is just to hook these up to alerts. At GitHub, we know that if 0 commits have been created anywhere in the world in the last 2 minutes. Like there's probably some sort of bug somewhere, so I want to get an alert about that. If I run like an e-commerce site and nobody has added anything to their shopping cart for 5 minutes, then I know I want to get an alert about that. If you think about your own site and you don't know where you'd want to add these right now, don't worry. Like, you will find the places where you need these as you break things that are important. I have a story about this. One time, right when I started at GitHub, it was like 4 o'clock in the afternoon, and I hadn't eaten lunch yet, and I was feeling really tired. I'd been working on this big pull request, and I just had like one little change that I had to make before I could ship it off. Like, it had already been reviewed by all my coworkers, and I was like, this is ready to go. Push it out the door. One tiny small JavaScript change that happened to disable the create pull request button. This was broken for like 10 minutes. Like, you went to go make a pull request, you filled in all the details in that little text box, you went to go click the button to submit the pull request, and it was just disabled for no reason. The page loaded really fast, like there weren't any JavaScript errors, but users still couldn't use this massive piece of GitHub's functionality. It's like a huge, huge problem. And of course, like, there were no alerts from our infrastructure. Like, we found out because someone was tweeting about it on Twitter. So afterward, when we were kind of taking apart like what happened in this incident, someone on the infrastructure team asked, was there any graph that this showed up on? And of course, like, we graph everything, so it's pretty easy to find. Can you guess where I broke pull requests? Sure enough, it shows up pretty clearly on this graph of our pull requests per minute. And for things like this, for these critical actions that your users do all the time, you want to be able to collect data on them, graph that data, and trigger alerts. If you want to get fancy, you can use derivative alerts, which will go off if there's like a sudden rate change. But in this case, we could have started really simply and just said, if there are fewer than n pull requests per minute, something is probably wrong, like fire off an alert. If your ops team doesn't want to give you the login to all their monitoring and alerting tools, you can actually set up alerts like this yourself in Google Analytics. It takes a little longer for the alerts to get to you and more on the order of hours instead of minutes. But you can at least use GA to get like text message and email notifications if your events go above or below a certain threshold, which I think is better than not knowing at all or having to find out from like 8 emails from users. So performance, user behavior, and errors are the big pieces. I think a lot of people are monitoring those. But there are all these other little things that we realized we wanted to know about how the site is working in real life. And we found that we could write integration tests or acceptance tests, but those tests never totally captured all of the variety in our real production data. And they never actually captured all of the weird things that users actually do in real life. Users will click on things you didn't think were clickable, like they'll install weird browser extensions that you didn't know existed. They'll open a page, then close their laptop for a day, and then like reopen their laptop and like trigger an ajax request from that same page after you've deployed new code. So we wanted to have a small army of canaries to kind of fly around and comb the site to see what it really did in real life. And of course, that army is GitHub staff. We just like volunteered them for this job. So when you're running the GitHub website in staff mode, we show you this cool little bar at the top of the page with all kinds of performance stats about the page load you just did. But we also have you download a few extra scripts behind the scenes. So when you run into a situation that we think is weird or bad, we can record it and send back a little report. I think one of the more interesting use cases for this is for security. This is a case where we don't care so much about the aggregated numbers. We want good data, and we just want to know whether something is happening or not. So content security policy exceptions are a great use case. People at GitHub are like really kind of obsessed with security and privacy, which I like. We try to do everything we can to protect against XSS or cross-site scripting attacks. So we set content security policy headers that are fairly strict, and we log CSP errors that staff encounter. So if there's a persisted XSS running a script and a staff member runs into it, we would actually send a report to Haystack, just like it's another JavaScript error, but they go to a separate place so we can see them by themselves and try and fix them. We also do accessibility monitoring. We try to keep github.com accessible to screen reader and keyboard users, but we don't have a whole full-time team dedicated to this, even though I wish we did. It's really just a few of us who work on it part-time in addition to everything else we do. So we came up with sort of a cool solution, which I think is fairly unique. Hopefully we'll open source this at some point. We have a set of accessibility checks in JavaScript, and we send those to staff. And then if we run into an accessibility issue, it throws a JavaScript error. and that'll send it back to our JavaScript error reporting infrastructure so we can see the reports along with everything else in there. This is a case for checking images without alt tags. That's definitely something we want to know about. It's kind of one of those canonical accessibility issues. So we're creating a custom error class so that we can kind of filter those out and like put them in their same bucket together. Another case we look for is links that don't have text content or don't have an ARIA label. This is really common for us since we use so many icons around the site in lieu of text. So it's really easy to accidentally use an icon that makes sense to someone who can see it visually, but doesn't make sense in a screen reader. This is a big problem because screen readers will announce that there is a link, but then they won't tell anything about where the link goes, which is obviously really frustrating. So again, same thing, we create a custom error class, and then if we see the situation, we throw an error, which will send back context information about where this is. And the other big case we've run into, this is a big problem that is surprisingly common, is forms that, form labels that don't have any inputs connected to them, and form inputs that don't have a label. Like visually, these forms all look right, because people always try to do the right thing and label their form inputs, and they just get the syntax wrong. Like people forget if it's like the ID or the name that goes with a for attribute. It's just confusing. So we check for this in an automatic way with JavaScript, and then when the script finds one of these accessibility issues, it does two things. One, it writes a little warning into the console, where hopefully the developer who's like working on adding this feature will see it. But the other thing it does, like I said, is send off that custom JavaScript error to Haystack so that if someone has a little bit of time, they can go and knock out a bunch of these accessibility issues all at once. Some people ask, like, wouldn't you want to test for this? And there are some cool tools for testing accessibility of your pages. Like there's Capybara Accessible, which lets you use Capybara, the testing framework, to add accessibility testing to your test suite. And it's cool. It worked pretty well. But it's pretty hard to get that check to run against every page of your site. And of course, it's probably going to run against your test data, so it's not actually going to replicate all your real production data. This, on the other hand, is easy to set up. We write the scripts once, and then we let our people who are looking at the site anyway basically use their browsers to run all these checks for us. It's been working pretty well. We'd love to add more checks in the future and hopefully source that library. The final thing that we've started tracking recently, which has been kind of interesting, is we want to track browser feature support. We like to test out new browser APIs as soon as we can and get rid of polyfills as soon as users don't need them anymore and as soon as most browsers support them. So we run a series of really simple feature checks. We just sort of, often it's just as simple as looking for like a property on window to see if a browser supports a particular API. And then we just collect up that object and send it back. And then, of course, we graph those. And so we can sort of watch. This is a 3-month graph. And you can see that that purple colored line is the percentage of users who needed a polyfill to support emoji, which is pretty cool. You can see like right when Chrome rolled out emoji support. We could try to get this information from tracking browser versions and looking things up on a site like caniuse.com. But browsers change versions so quickly now that it can be pretty hard to figure out what your user's feature support is really like that way. Like you kind of have to like look through all these tables and then like calculate the percentage of your users with each version. And this is actually more accurate and it's pretty easy to set up. So a lot of people ask, like, I worked at a small company. I don't have the time and resources to build all that stuff you just showed. Like, where should I start? You definitely don't need all those pieces that I just showed. To get up and running with the minimum, you can start with some out-of-the-box services. For JavaScript errors, New Relic does a lot of stuff that Haystack does out of the box, and that'll also handle like sending you notifications when things get weird. Errorception and Bugsnag also do JavaScript error reporting, and then Raygun, who's one of the sponsors, I think they also do it. For browser performance, like there's tons and tons of options here, and a lot of them are really good. New Relic is one of my old favorites. But my personal like #1 choice is LogNormal, which is part of SOSTA. And I really like it because it does histograms for every page load in addition to those normal line graphs. And it also breaks up performance by country, which is really great if you have a lot of users in the US and in New Zealand, where loading performance will look really, really different. And of course, Google Analytics also collects performance metrics by default. Not everyone knows this, so if you haven't taken a look at the perf stats in there, you should jump in because it's already collecting them for you. On the graphs and alerts side, Circonus is my favorite tool for storing all your perf data and making it into pretty graphs and dashboards. If you're using sending browser data to Circonus, you'll have to set up a little service to aggregate it, but it's doable. Circonus is also great because it lets you set up really complex alerts from the browser. But I think the best answer for a lot of this stuff is that you should, if you work in a company where this is possible, you should go talk to your ops team. You should find out what they use for graphing, monitoring, and alerts. And then you should see if you can use it too. The best part about that is then you'll have a built-in group of collaborators who also care about this stuff, who can help you if you run into any problems. If that's not possible in your organization, remember that Google Analytics is great for tracking user metrics and performance metrics. And like I mentioned, you can also get notifications from GA. It can email you or text you alerts if your metrics change. And that's definitely enough to get you started right there. So we talked about the how and the what. But why do we want to go to all this effort? There are two reasons. The first is it'll change how you write your code. So many front-end techniques and tools became popular because they had this willingness to never throw an error and never stop working, no matter how weird the code was. Back in the olden days, this is a long, long time ago, I remember I always wanted to migrate from XHTML strict, or to XHTML strict from XHTML transitional. But if you worked in a CMS or with other team members, this was really scary to do. Like with XHTML strict, there was this possibility that you could leave off a closing tag in the wrong place, and all of a sudden you'd start shipping your users a blank white page and have no way of knowing about it, which is rightly really terrifying, so no one ever did it. This is also, I think, part of the reason that jQuery was so successful when it first came out. jQuery by design almost never throws errors in cases where DOM APIs often would. So this is a great example. If you want to use a native DOM API to add a class to an element, you'd do this. You'd be query selector tab, classes add selected. Of course, if you're not sure if tab is going to be on the page or not, if tab might be undefined, you would have to do some extra work to make sure that that didn't throw an error. But of course, in the jQuery case, jQuery don't care. You can add classes to an empty set of DOM nodes all day. I think that was amazing and absolutely the right decision when jQuery first came out. But if you have good monitoring, you find that you don't want that anymore. You really want errors. When we expect an element to be on the page and it isn't there half the time, we want to know about that, and we probably want to fix it and write the code in such a way that it makes that clear. It makes it a lot easier to debug a problem than if you're trying to reason about this ball of jQuery where half the queries return no elements. Another thing that people ask is, why would you add monitoring when you could write tests for this stuff and catch it before it even happens? And I agree. There's definitely some overlap in what you can catch with monitoring and what you can catch with tests. But there are things that you just don't want to write integration tests for that might still be important to you. And I say this as someone who spent multiple days of my life trying to write an integration test for a drag-and-drop image uploader. I don't recommend that. Just don't do it. So this is another tool you can have in your tool belt in cases where writing tests might be impractical. Plus, tests catch problems when you run them, which is usually when you change stuff. I know that sounds really obvious. But of course, you have to remember that the environment that your code runs in is actually changing all the time. This is an error graph that looks like it's from us rolling out some new broken JavaScript. But that's not actually what happened. This is what happened when all of our users' browsers started auto-updating to the latest version of Chrome, which changed some API. Tests give you the illusion that you can verify everything each time something changes, but the environment around your front-end code is changing all the time. I love this quote from Daniel Espezet, who's on the front-end infrastructure team in Etsy, who says, "The browser is part of your distributed system. It's not just a client that you support." And I think it's a particularly volatile piece of your distributed system, so these are the tools that help you manage that volatility. The second reason to do all this is that instrumentation and alerts help fewer people in your organization be code janitors, people who wander around cleaning up other people's bugs. I end up doing this all the time, so I know how it goes. This will help you find bugs sooner, usually so soon that it's easy to have the person who created the bug go fix that bug. And as a bonus, your support team will get fewer emails from frustrated users. Internally, our ops team is making it easier for any GitHub developer to set up alerts for themselves on an application. So it's not just the ops team that can get paged now, too, with this stuff. The ops team gets paged if someone restarts the master database by mistake, but I can get paged if ajax requests are suddenly getting slower only in Firefox. And all of this leads to a big culture difference. You end up feeling so much more empathy for your users because you can see them run into problems in real time. But we also have this shared empathy now for the ops team, now that we have to deal with all the same pagers, like the pager and all the same tooling that they have. And we can better tune our sensors to what's risky and what's not, what causes problems and what doesn't. And it's a very valuable tool to have. So I said I'd come back to this, like what is my job really as a front-end ops engineer? I work on a team called the JavaScript team, but about half the company writes JavaScript. The thing I do that's different involves all the tools that are around the JavaScript. I help set up the tool chain, I watch the monitoring, and then when I see patterns in what's slow or broken or dangerous, I help fix them. You fix the bug, you fix the framework under the bug, you fix the safety net around the bug with alerts, tests, and metrics. And that's what you really need to make the system safe. There are about 5 people at GitHub who spend some portion of their time doing this work that I do too. But there's probably about 50 people in the company that write JavaScript. And I should say, I don't actually want to expand my team to include all 50 of those people. Like, the people with domain expertise should be able to write their own feature JavaScript. Our job is just to put tools in place to make it safer and easier to write that code. I think more companies should probably have someone who does this type of work. So if you think someone in your organization should have this job too, tell your team you need a front-end ops engineer. Thanks.